I thought it'd be good to make another talk. Short talk on astronomy number 3. Here we go. Over time, I learned that a lot of establishment scientists and people who want to preach, well, you're not correct unless you have math involved, is that they don't want to explain what they're talking about. They want to make it to where, oh, well, if you don't understand math, you couldn't possibly understand what we're talking about. They want to have their little pedestal. That's what they do with math. And what they also do with math is that they confuse people with it. They use all these strange mathematical concepts and mathematical objects and, whatnot. They take numbers and they justify all their theories with random numbers. That's what they do. And I think this all began literally not with Einstein, but with that era, with like 1905 to 1915, 1920s. And they went overboard with it. They took something really good that could quantify things and was very, very useful, and they went off the deep end with it. And they went off the deep end in two aspects. The first one was with things that are really, really, really small, tiny, tiny, tiny. And the other aspect, number two, is what I want to go into with this talk, is the things that are really, really, really big, such as galaxies, stars, the universe. Big, big structures here. Going to use math means you have to have some type of physical understanding before you use the math. You have to have some type of conceptual basis of what you're referring to. You have to have physical understanding involved before you even think about using math. Mathematical physics is not physics, it's math. But what happened in the 1920s, 30s, 40s is, since our technology wasn't advanced enough to observe the stars, I mean, sure, we had some good telescopes, but they started inventing mathematical things concerning the stars, and then basing all those things off of even earlier mathematical theories concerning the stars. And before you know it, stellar evolution models became mathematical models that you can model with computer simulations. Stars aren't mathematical models. Stars are physical, man. They evolve physically. So what happened was they were engaging in what I would say what was rainy day physics. They didn't have enough observation. They didn't have enough to go off of to actually make sound judgments off of what it is that they are observing. So instead of making sound, reasonable judgments, they thought, well, we have this thing called math, maybe we should just use that to explain everything. And that's what they did. They tried to use math to explain everything. But math can only go so far. You actually need physical observation. You need understanding of what you're referring to. You need a conceptual basis before math can even be applied. You need to conceptualize what you're referring to. You need a qualitative understanding of what you're referring to. Now, I remember I watched this one video with Jeremy Dunning Davis overviewing the time when he worked on this one paper and did all this work, and he showed it to his professor, and his professor, said an expletive and said, "What is this? What does this mean? What does this physically mean?" Because he didn't have any physical conceptual basis to his paper, which was probably very mathematical. Now, I want my readers to understand and listeners to understand that if people online, if they say, well, if you don't understand the math and you can't possibly understand what we're talking about, I want you guys to understand that they're just as clueless as you are. Chances are more likely. Sure, they probably understand math, but math isn't conceptual, physical understanding of nature. Numbers, they don't really exist. They're just concepts we use to quantify things. But quantifying a tree, such as 1 tree, 2 tree, 3 trees, is not understanding the tree, not understanding the billions of cells that make it into what it is, or understanding the complexities of biology that are involved with the tree, how leaves grow, how old it is. Math just is used for counting purposes. It has no physical understanding. There's no physical understanding in math at all. It's just a qualitative thing. So when you look into astronomy related matters and you see a lot of math, chances are they're dodging something. They're trying to explain away something. But if you see math, you should know that math isn't an explanation. When you see math, you should realize that they're clueless. They don't know what they're doing. Because it's used as a filler now inside of physics. It's used to keep people busy. It's busy work. Math mostly is just busy work now, in place of actual physical understanding. And I think they like the idea that you could just do math and supposedly have understanding, but after what I've experienced, math isn't required to make great discovery. Math is absolutely meaningless when it comes to discovery and insight. Sure, now after the discovery is made, we can use math to measure things, and how maybe a star shrinks its diameter as it cools and dies, and measure the diameters of stars as they cool and die. That uses math. We can measure the heat production and give that a number of stars, But to actually understand that the star cools is meaning that the heat production diminishes. And then we can, measure that. But you first have to understand that the star is going to cool and die. You see what I'm saying? It's not going to remain hot and bright forever. I think for the most part, anybody, if you really want to get understanding of the world around you, you have to keep an open mind. And don't think that you have to study math to get there. You don't. You can just use your brain and conceptualize different ideas. That's all you really need. But to measure things, yeah, you need math. But that's all it's really good for. And to say you need math to understand something, no, that's not true at all. You need math to measure something. To understand something takes this.